Our review is some of those words that are commonly used in math. We want to make sure that you have an understanding of what those are so that when we use them throughout the rest of the semester, you're not confused by those. So we're going to go over some of those, and that's what your practice is going to be tonight. Your homework is all words, and you turn it into math symbols. Okay? So some of the words we're going to talk about. Here's the first one. So this is just a review of different math vocab. We're going to talk about words that mean addition and subtraction. So you're going to see addition's usually pretty easy. More than, sum, increased by, those are all words that are going to mean addition. So you might, go back. There we go. I'm going to pause it a minute. All right, increased by. Anybody else think of any words that would mean that you would think of when you think of addition? Those are a couple of the ones I came up with. So you might see something like 3. No, it would all be words. 3 more than 5 times a number. So you're going to see that expression, 3 more than 5 times a number. And then your job is just to make that into what that means in math, using math symbols. Okay, so the homework's not going to be too hard. Anybody want to take a stab at that one? 3 more than 5 times a number. Yeah. Say that again.
5n plus 3.
Okay, 5n plus 3. Anybody else want to try something different? Would 3 plus 5n work? Okay, why?
Because it's the same thing.
Okay, in addition, and in addition only, it has the commutative property where the order doesn't matter. Okay, now, did she have to pick the letter n? Could she have done 5a plus 3 or 5x plus 3? Okay, any of that is totally fine. All right, she's picking a variable to represent the number, and then the order in addition doesn't matter. All right, other words that you need to be familiar with is the difference between less than versus less. Now, both have something to do with subtraction, but they have different orders. And so you have to be sensitive to what the order is and how it would be written differently. So, for example, you might have 4 less than half a number compared to 4 less half a number. And so they both imply subtraction, but the order is going to be different. So one of them is less than, and the other one is just the word less. So when it says less than, which part is the bigger part? If it's 4 less than half a number, which part is bigger, the 4 part or the half a number part? The bigger part is the half a number because it says 4 is less than, so 4 is smaller. And so since 4 is smaller, then you have to write it 1/2 n minus 4. That would be the order because because it's smallest, 4 is less than, you're going to put the 4 after the subtraction. Okay, compare that to if it just says less. If it doesn't say less than, if it's just less, then it's 4 less or 4 subtract half a number. And so those are different things. Subtraction is different than addition. In addition, you have the commutative property where the order does not matter. But in subtraction, you don't, and the order does matter. And so you want to make sure that you're watching that real carefully for that word than. All right, some other things. That's topic number 1. Number 2. Some geometry vocab. So throughout the course of the year, you're going to have geometry creep up every once in a while. Okay, we might have some area problems, some perimeter problems, so you're going to have to take the words and turn it into math. Okay, and so you might have find the perimeter of a rectangle shape whose length is 2 less than its width. So now you've got some subtraction words in there. You've got less than, whose length is 2 less than its width. You have that, and you have the perimeter, and we have to put all of that together. All right, what's bigger, the length or the width? Okay, the width is larger. We're going to start with that. So we're going to call that W. Then we go on to length. The length is 2 less than the width. So we talked about how to write that, where you have 2 less than. The 2 is less than, so it's smaller than the width. And so you have to write it as W minus 2. When it says less than, the 2 is the part that is the subtracted part. So you take the words, you change it into expressions for width and length. Then you need to write perimeter. And hopefully you remember that the perimeter of a rectangle is made up of what? How do you find the perimeter? All sides. So how many of the widths? 2 of the widths and 2 of the lengths. All right, and so we would have 2 of the widths, so width plus width, that's 2 of the widths, and then 2 of the lengths, so W minus 2 and W minus 2. And then you kind of put all the like terms together. So you've got 4 sides added up. And so all together, does anybody want to simplify that for me? It's okay, just say it out. Okay, 4W minus 4. Okay, good. And so that would be the expression. All right, that would be one of our examples. All right, a second example, let's try one with a triangle. So find the area of a triangle shape whose base is 3 times its altitude. And altitude is another geometry word that actually means what? Do you remember what altitude means? It does. It means height. And so altitude is another word. It's a synonym for height. So find the area of a triangle whose base is 3 times its altitude. All right, what's smaller? What part of this is smaller right now? The altitude smaller or the base smaller? The altitude is smaller, or the height. And so we'll start with that. That's the least complicated. So the altitude, maybe we'll call that h because it stands for the height. The base is 3 times the altitude, so the base would be 3h. So h for the altitude, 3h for the base, and then we have the area that we're trying to do. All right, who remembers how to find the area of a rectangle? I know geometry has been a long time since you've done that, but anybody remember? Say it again. Base times height, that's going to be for a rectangle, and then half of base times height, right? So it's base times height divided by 2. And so in our situation, it would be 3h times another h divided by 2 for a triangle. And so when you multiply 3h by another h, that's not 4h. That's 3h times h is 3h squared over 2. And so that's our area. Okay, very good. All right, let's keep going. We have 2 more topics we want to talk. So our third topic is the idea of percentages. All right, when you have a percentage, when you take off the percent sign, what do you have to do to the number when you do that? So like if I say 75%, okay? And how do you make it a decimal? Which direction? Okay, how many spots? Okay, you move it over 2. So most people remember that. Take off the percentage sign. You're going to move the decimal place 2 points to the left, but there's a second thing that you have to do, and a lot of people forget that. So let me remind you of that. So you're going to take off the percentage sign, then you're going to move the decimal 2 spots to the left, and then the second part that you have to remember to do, and you have to add a variable. And that's the part that most people forget, is the add the variable part. Add is a bad word because I don't want you to think it's a plus sign. Let's try attach a variable. That would be better. Okay, a better word. Attach. Okay, so take off a percentage sign and then move the decimal and then attach a variable. So, for example, if you have 75% of the price, when you take that percentage sign off, it would become 0.75, but then it has to have a variable on there. And because that X is representing what the price is, you don't know the value, and so you have to have a variable to represent that. All right, so a couple examples that we would do. All right, what would you pay if a tag said 35% off? And then the second question, leave a space for that. What would you pay if tax is 9.25%? All right, so those are 2 questions about percentages. How do you turn that into, and I didn't tell you the price, and that's fine. You don't need to know the price right now. We're just turning it into a math statement. What would you pay if a tag said 35% off? And what would you pay if the tax was 9.25%? All right. When you have something that is 35% off, in both of these situations, you have to start with the number 100%. Because you have to start with the value of what it is that you're paying to begin with. So in this situation, it would be 100% minus 35%. And in the second situation, you still start with 100%, and then you add 9.25. So we're not taking the percentage off quite yet. We're starting with the percentage on. And if we have 35% off, we're going to subtract. How much percent would that give me in the first subtraction situation? 65%. Now, take the percentage off. And so then you would take the percentage off, and you'd have 0.65, and you would add X to represent the unknown price. If you have tax and you're adding, we're going to add 100 and then the 9.25%, which is going to be 109.25, which is the decimal to represent the fraction. Okay, a quarter becomes 0.25. After I've added it together, then I take the percentage off, and I'm going to have 1.0925 and then X on that. Or you could use P to stand for price or some other variable, but you need to attach a variable. So the thing I want you to remember is when you have a percentage, Don't just take the percentage off. Take the percentage off to move it and add a variable onto it. All right, last thing. Okay. Are the last words you have to translate per versus each. So you owe, for cable, you have to pay $79.95 per month or each month or something like that, those words. When you see those words, again, you're always going to attach a variable. That's what those words are going to mean. Okay, the word per, the word each, just like percentages, you need to attach that variable to represent the unknown. And when you see per or each, you want to attach a variable. All right, so let's practice an example of how that might show up in a sentence. Okay. Write your credit card balance. If you owe $1,225 plus 16% interest less $150 each month. Okay, how would you write that? Translating all those things. So we've got percent, we have plus, we have less, we have each. We have all of those things. We've talked about addition, we've talked about subtraction, we've talked about the word each, we've got a percentage here we have to deal with, we've got all this stuff going on, okay, all in one problem. All right, does anybody want to try it? Think about it a minute, or even try part of it.
So we could write it like it's negative because you owe money, right?
Okay, well, a credit card statement, I don't think the way they don't say that you're going to have, they start with positive money.
Of course.
So, so we're going to start with $12.25, I think. All right, I'll show you. So we've got $12.25. Oh, oops, not 1. $12.25. Okay, plus. Now the 16, I want to take off the percent, move the decimal, 0.16, and then what do I put after that? Okay, X would be if you didn't know the price or didn't know how much you had. And I do this time. Okay, so yeah, normally we would put an X if we did not know how much money we were working with, but we do know how much money we're working with, so we were going to put $12.25 there. Then we come across less. So we know we have subtraction. Is this less or less than? Does the subtraction come at the beginning, or should the subtraction come at the end because it's less or less than? It should be at the end, right? If it had said less than, we would have put the subtraction in front and put the other stuff in front. This would be at the end. And less, 150, and then the word each there, which I don't know how many months there are, and so there's where my variable is going to be to represent the word each. So if I didn't know the price at the beginning, I would have had two variables there.